Welcome to day 4. You got day 4 homework tonight to be working on. Be taking out your calculators, be taking out your homework to be able to check the answers in a minute, and our warm-up sheets. You can put the warm-up sheet, if you don't have today's box available, put it where you have a free box. And reminder, you've got problem set due on day 8. Which is coming up pretty soon, so be sure to be working on that as well. So we're going to pause for 3 minutes to allow you to do the warm-up. All right, so we've got our 3 central angles there. Whenever we have a ratio like this, we want to put a variable after each. Make sure it's a variable that's not already in the problem. We didn't have any variables, so I'm just going to use x. So AOB we had is 2x. We've got BOC is 3x, and then 5x for this one. Well, the angles around a point should add to 360. So we got 5x plus 2x plus 3x equals 360. So that'll be 10x equals 360. When you divide by 10, you just get x is 36. So if we fill each of those back in, 2 times 36 is 72. If we did 3 times 36, that's 108. And if we do 5 times 36, that's just 180. So the measure of arc AB should be identical to the central angle, which was 72 degrees. BC should be the same as the measure of its central angle, which was 108 degrees. And AC would be 180 degrees. We'll move over to the homework from over break. Pretty similar, but with arcs here. So put an X after each of them, add them up to 360, you get X is 20. Fill back in, and you get each of your values of the arcs, the 100, the 140 for BC, and the 120 for AC. They told us we had perpendicular for DO and OE, so that one's 90. And then the other two were equal. So pick a variable. I picked X. So X plus 90 has to equal 360. That means each of those individual ones are 135. So we've got our 3 central angles, and then the 3 arcs which they open up to. They told us 1, 2, and 3 are angles, but they didn't tell us 4. So pick a variable for it that's not in the problem. I chose X. They should add to 360, and you got X is 70. Well, once you know that angle 4 is 70, arc AB would be 60, because that's its central angle. And then arc DAC would be this arc here, because we want to go D to C, but A has to be somewhere in the middle. So we're adding up the 70, the 60, and the 100 to give us 230 degrees for that arc. So they gave us 3 algebraic expressions for our 3 arcs. They must add to 360. So start up, add them up to 360, solve for x, we get x is 45. When we sub them each back in, we get 95, 115, and 150 for the arcs. Well, that answers part A, the arc for CD. Our central angle DOE will be the same as the arc it opens up to, 115. And then EOC is the same as its arc, so 150. And that's it for that part. So let's flip over to 24. And our main new thing today is to look at inscribed angles. So first off, a couple vocab words. A chord is any segment whose endpoints are on the circle. So in that picture there, both AB and BC would be considered chords because they're line segments whose endpoints are on the circle. An inscribed angle, which is what we're going to focus on mostly today, is when the vertex of your angle sits right on the circle. So notice the vertex of our angle at B is sitting right on the circle. That's what makes it an inscribed angle. Just to compare this to, here was our central angle before, when our vertex is at the center of the circle. Okay, so just to compare the two. Central angle on the right, inscribed angle over on the left. Central angle, if this was, say, 80, this was 80 as well. It's going to be different for an inscribed angle. If you have an inscribed angle, the measure of the angle is half the measure of the arc it opens up to. So, if this arc was 80 degrees, the inscribed angle would be half of that, so 40. And that's the big new thing for today. An inscribed angle, an angle whose vertex is on the circle, its measure is half of the arc it opens up to. So if we look at number one, let's start with angle A. Angle A, if we follow to see where it hits the circle, it's an inscribed angle that's opening up to that arc. So angle A's measure should be half of the arc it opens up to. So half of 100 is just 50. Angle B is an inscribed angle because the vertex is on the circle. And angle B opens up to the 150 degree arc. So angle B would be half of that measure, so 75 degrees. And then C is half of the 110 that it opens up to, so 55 degrees. Well, let's think about why it makes sense that it's half. Notice we had a triangle form there. Triangles we know add up to 180. But circles, the degrees all the way around are 360. Because 180 is half of 360, that's why the inscribed angles will always be half of the arc that they open up to. All right, in 2, they tell us we have a diameter for CB. Well, knowing we have a diameter, that means we know that this arc has to be 180 because it's half the circle. They tell us that we have circle O. So keep in mind the circle's name is its center, so that implies O is our center. And AC, they tell us, is 120 degrees. In most of the problems we do, if you can find all the arcs, you could answer any question they could throw at you. Well, we're only missing arc AB. Down here was 180, so the top half should also be 180. Well, if that part's 120, that means that AB's remaining part should be 60. So now let's see if we can answer the questions. So angle COA, notice its vertex is at the center of the circle. So we're looking at this right here. So a central angle, from what we saw before on the previous days, the central angle is always equal to the arc it opens up to. So that one is just 120 degrees. CBA, though, this angle right here, its vertex is on the circle. So its measure is going to be half the arc it opens up to. So let's trace it and see where does it hit the circle. Notice it hits at C and A. So that angle CBA is going to be half of the arc that it opens up to because its vertex is on the circle. It's opening to a 120, so half of that is 60 degrees. So far we just found that this one was 120. This one was 60. Well, now we want angle BAO, which is right here. Something we saw on day 3 several times is to be on the lookout for radii in your picture. OA is a radius, OB is a radius, and OC is a radius. So all 3 of these segments should be identical. Well, that makes that triangle on our right a isosceles triangle. So the angles across from the congruent sides should be identical, meaning that angle BAO is also 60 degrees. So be on the lookout for radii in your picture. If there's multiple radii in a triangle, that makes it be an isosceles triangle. And we can use the fact that isosceles triangle implies 2 congruent base angles to help us get other angles. In 3, we've got circle O, so that means we know O is the center. BAC is 40 degrees, so let's label that in our picture. And AC is the diameter. If AC is the diameter, we know this has to be half the circle, so this arc is 180. Well, always see if you can find all the arcs to start out. Well, notice this 40 here is an inscribed angle. Its vertex is on the circle. It opens up to arc BC. Inscribed angle should be half of the arc. So if our inscribed angle is 40, that means this arc should have been 80. Well, if the bottom half of the circle there, AC, was 180, the top half should be 180 as well. Because we already had 80, that means AB must be 100. So I like to, if possible, find all the arcs before even looking at the questions, because again, you can answer any question they throw at you if you've got your arcs. And notice we've already answered some of the questions. BC was just 80 degrees. BA arc was 100 degrees. And now we want angle OBA. So OBA is right here. Keep in mind we've got several radii, here, here, and here. In a circle, all the radii are congruent. That makes our triangle there isosceles. The 2 congruent sides should have congruent base angles across from them. So OBA is also 40 degrees. And then to finish this off, BAC are arcs. So we're going from B, from A, all the way to C. So we've got 2 arcs to add up there, the 100 and the 180, which will just give us 280 degrees. All right, and 4, let's label what they show us. We've got 60 degrees for this arc here. And we don't have any other arcs we can find based on the information, so let's just kind of go from here. We want to start with angle Q. So this one here. The thing to notice is Q's vertex is on the circle. So therefore, it is going to be half of the arc it opens up to. Well, if you follow angle Q, it hits the circle at R and at P. So it should be half of this arc. Half of 60 is just 30. So angle Q here will be 30. Well, let's look at angle S. We want to recognize that angle S's vertex is on the circle. That makes it our new thing for today, an inscribed angle. Inscribed angles are half the measure of the arc it opens up to. So let's follow this angle S and see where it hits the circle. It hits it there. It hits it here. So it's going to be half of this arc. So it is half of the 60 as well. So its measure will just be 30. So the reason those are the same is both those inscribed angles are opening up to the same arc. so they're half of the same thing, which is why they are equal. Now, if we peek at P and R, first thing to notice is that P and R are both inscribed angles, and they are both opening up to QS. So what must be true about them? Angle P should be equal to angle R, since they are both inscribed and open up to arc PR, or sorry, arc QS. So inscribed angles that open to the same arc should be equal because they're half of the same thing. All right, so here they tell us some arcs. We've got arc AD is 70, arc AB is 80, and arc BC is 100. Well, we should be able to find arc DC as well because they should add up to 360, all the arcs in the circle. So if we do 70 plus 80 plus 100, then we can just pick a variable that's not in the problem. X is not in our problem. And then equals 360. Well, this is going to give us that 250 plus X equals 360. We'll subtract the 250 over, and X is just 110. Well, we want to find the measure of each angle. Well, let's start out maybe with angle A. Angle A hits the circle at D and B. So angle A, which notice it's inscribed because it's on the circle, is going to be half of that arc. So together, those are 210. If we take half of 210, we'll get 105. So that's angle A. Let's go to angle B. Notice angle B is inscribed, and if we follow and see where it hits the circle at A and C. So it's opening up to this arc for angle B. Well, if we add those together, we get 180. Because it's inscribed, it's half of the arc, and half of 180 is 90. C is opening up to the 70 and the 80. So together that's 150. Half of 150 is 75. And D is opening up to the 80 and the 180, or the 80 and the 100, sorry. So that adds the 180, so half of that is 90. So we want to look at the opposite angles in this quadrilateral. Now, first off, this quadrilateral is considered an inscribed quadrilateral because all of the vertices are sitting on the circle, and in other words, making them inscribed angles, our new thing for today. So look at our opposite angles. We have 90 and 90. Notice together that gives us 180. The other two opposite angles, you have 105 and 75. Together, that gives you 180. So the opposite angles in our quadrilateral are always going to be supplementary. Now the reason for that is the arcs that they're half of when you put them together will always be 360 because they're going to be opening in opposite directions, and half of 360 will always be 180. All right, so the next one we've got parallel chords. I'm going to put our little arrowhead because that's our symbol to mean parallel. Angle 1, they tell us, is 35. Well, based on our zigzag from alternate interior angles, when you have parallel lines, it gives us congruent alternate interior angles, so this is 35 as well. You'll notice angle 1 and angle 2 are inscribed angles because their vertex is on the circle. An inscribed angle is half the arc it opens up to. So if angle 1 is 35 degrees, QS should be 70 degrees, and likewise, PR is 70 degrees. So we get those for each of our arcs. And the key thing to recognize here is when you have arcs that are in between parallel chords, they are congruent. And this is a property that does tend to come up a decent amount. So if I give you two parallel chords, we automatically know the arcs between them are congruent. If I told you one of them is 50, we know the other one has to be 50 as well. Okay, so that is a property that will come up a decent amount. Now, the thing that I always visualize, if you've ever played pool before, you have the balls are solids and stripes. I always envision it of, oh, the stripes on the striped balls, they really have like parallel chords. And so like the curved part of the ball is the same amount when you're looking at it on the stripes. All right, next one. They have ABC is inscribed in a semicircle. So that means the top half of this, the ABC, is 180, meaning the bottom is 180. Arc BC, they told us, is 54. Well, if the bottom is 180, the top has to be 180 as well. So we could do 180 minus 54 to get 126, and that'll give us what AB is. So we got 126 for AB. AC was 180 because they told us ABC was inscribed in a semicircle, meaning it's on the top half of the circle. Angle A is inscribed because its vertex is on the circle. The new thing for today is when you have an inscribed angle, it is half the arc that it opens up to. It is opening up to a 54, so half of that would be 27 degrees. Angle C, notice it is on the circle, so it is inscribed. Our new thing for today is when you have an inscribed angle, the angle is half the arc it opens up to. It's opening up to 126. So half of 126 would give us 63 degrees. And then angle B, notice, is on the circle, so it is inscribed. Our new thing for today is an inscribed angle is half the arc it opens up to. It's opening up to the 180, so half of that is 90. So ABC was the angle that was inscribed in a semicircle. So our little property there is an angle inscribed in a semicircle is right. Because if it's inscribed in a semicircle, that inscribed angle will always be opening up to a 180, and half of a 180 is always 90. All right, moving over to number 8. They tell us the measure of angle D is 25, so we can label that. With these problems, you're always going to be given some information, and you'll have something you want to find. But there may be connections in between that you have to make to get from where you're given to what you want to end up with. So a good strategy is to just start writing anything you know to be true. And eventually that'll lead you to what you want to find. Now notice in both these, we have circle A, which implies that A is the center of our circle. So to find X in letter A, that's a central angle, meaning if we can figure out the arc BC, then our central angle will be the same as that arc. So that's kind of our goal. Well, they gave us angle D, which we want to recognize its vertex is on the circle, meaning it is inscribed. Our new thing for today is that an inscribed angle is half the measure of the arc it opens up to. If you follow angle D hits the circle at C and B. So the D is half of that arc. 25 is half of 50. Well, our central angle now should be the same as that arc, so x is just going to equal 50 degrees. If we go over to the next one, they tell us angle D is 15 now. Notice we do have a central angle again, and there's a couple different ways that we could go about doing this one. We're going to show you each of those ways. First, we could start out kind of like we did the last one. The inscribed angle should be half the arc it opens up to, so this should be 30. Well, if A is our center, that means BD must be a diameter, because it passes through the center, meaning this bottom half is 180. Well, that means that this part up here should also be 180. So if we have 30, that would leave us with 150 here. And then your central angle is the same as the arc it opens up to, so x is just equal to 150 degrees. So that's one way you could do that problem. Here's a second way we could do this problem. And in these circle problems, there's often more than one way. We could recognize that we have a bunch of radii here. AB, AC, and AD are all radii. So all those lengths should be congruent because all the radii in a circle are congruent. Well, this now creates an isosceles triangle, making this angle C also 15. And then the angles in a triangle have to add to 180. 15 and 15 is 30, leaving us 150 for angle X. So that's two different ways we could go about solving that problem. So next they tell us angle B is 32. We want to recognize that is an inscribed angle. Hopefully by this point, you're saying in your head, our new thing for today is that inscribed angles are half of the arc it opens up to. So follow angle B, see where it hits the circle. It hits it at C and D. So that 32 should be half of arc CD, so that means this is 64. If we make some connections, putting the last two problems together, angle A is a central angle opening up to 64, so this is 64 as well. And then we've got radii. AC and AD are radii, so they should be congruent, meaning our base angles in the isosceles triangle are the same as well. So we could call that x. Now just set up a little equation. 2x plus 64 should equal 180. If we subtract our 64 over, we get 2x is equal to 116. And divide by 2, and we get x is just 58. So inscribed angles are big today, that half the arc gives us the angle. We still have central angles from our previous days that they're equal to the arc. And then we've seen a little today and from previous days, be on the lookout for those radii, that they are congruent. That can help lead to isosceles triangles. Moving over to part D, we've got the angle D is 19. Hopefully, based on the last few questions we've seen, automatically you're making the connection. That's an inscribed angle. So it's half the arc it opens up to, meaning that this has to be 38. Well, this question is pretty much identical now. So that whole arc is 38. AB and AC are radii. So this whole angle here we could also call x. So we'd have 2x plus 38 equals 180. Subtract the 38 over, we get 2x equals 142. And when you divide by 2, we get that x is equal to 71. All right, our last problem for this video We've got circle A. So the connection we have to make from circle A is if it's the name of the circle is its center. So that implies A is our center. BC is a diameter. Whenever they tell you have a diameter, keep in mind that tells you all this is 180, and the top half would also be 180. They tell us DAC is 100. Well, if BC is a diameter, then that means that this must be a straight line, making that 80. And they tell us that EC is equal to twice the measure of BD. Well, notice we can find arc BD now because that central angle is 80, meaning that this arc is 80. So if we double BD, that should give us EC, meaning that this is 160. Well, keep in mind, bottom half is 180, top half should be 180. So if this arc is 160, we've got 20 left over for that spot. Well, they now want us to find the measure of arc BAE, this angle right here. Remember, A is our center, so that's a central angle. Central angle is the same as the arc that you open up to. So angle BAE would just be 20 degrees as well. Arc EC we already found was 160 degrees. And arc DEC. So we're starting here, going to E and then to C. So we're adding together the 80 and the 20, which is 100, then the 160, which will give us 260 degrees. So the big new thing for this lesson is an inscribed angle, which is when the vertex of the angle is on the circle. That angle's measure will always be half of the arc that it opens up to. That's it for this video. Any time left in the period you can use to work on the homework or the problem set. Have a great rest of your day.